All right, so this is what the process will look like to make the beads on day one. So first you're gonna get your alginate, which is just with food coloring. And then what your teacher will do is bring around 20 milliliters of this yeast solution, which is gonna be the exact same volume as your alginate. And then you're just gonna mix together the yeast. So you've got the yeast, which is producing your enzyme that's mixed with mix with your alginate here. And then you've got your calcium chloride, which as you drop in these beads should kind of start fixing these together. And you want to get these so they look pretty uniform. And you're going to leave them in the calcium chloride for about 5 minutes. And then after 5 minutes, this is going to be the step where you can save these for the next time. So actually you can reuse this calcium chloride. So you're actually going to pour the calcium chloride and your beads through this net. And we can collect the calcium chloride, and then you're going to put your beads in here. And then you can store these in distilled water for the next class. So then this, you'll label these, and then this will be how you will find them for your next class. But so now we want to actually test this out and make sure that this will work. And so here's your 3% hydrogen peroxide. So that is your substrate. And we're going to just make a column where you have 50 milliliters in there. And then what we're going to do is take one of your yeast alginate beads, and you're going to drop it in here. And what you'll see is that there's a series of time where the bead produces oxygen. And then essentially you want to time that to see how long it reacts. So I'm just going to do a couple of these. And the key is being consistent with the timing. So, and we'll talk about this in class about when exactly we're going to time this, start and finish the reaction. But we're essentially timing how long it takes for enough bubbles to be produced that will cause that to float. And so we're looking at that one full reaction, how much time that takes. And so you can see you can get a lot of trials pretty quickly. But then what we'll talk about is what variable we're going to change in each class. And we'll see these should be good in the fridge for 2 days, but they might lose a little bit of activity. But that's the point. So how I'm actually going to try to get the rate of the reaction is to get this time. And you can notice that I'm looking for the exact moment that it gets dropped in. So you can see it kind of plunging down. And then right when it gets in, I'm reading the time. So it's something like 2.97. And then maybe even exactly 3 seconds. And then I'm waiting, once this reaction has fully produced the amount of oxygen to make the bead float. So I'm looking for this exact time when it stops sinking and starts floating. And so I'm looking at like probably exactly there, which is 5.16. And it's interesting, I did this before and I got something slightly different, but it will come out very, very similar. So I think this is the most accurate way to get the time, is look for the starting and ending time, and you're looking at seconds and hundredths of a second. So I think that will be the most accurate way to find the rate